Hi everybody, my name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing. I'm here at SPIE Photonics West 2024. I have the pleasure of being joined by Theodor Nielsen. Theo, thank you so much for taking the time. I appreciate it.
Thank you for having me.
And of course I'm with John Lewis, and John, thank you of course for being here with me.
My pleasure.
Is it NIL Technology? Is it?
NIL Technology or NILT, both goes.
NILT, I like it. For those who don't know, could you tell us about the company and what you do there and what you're most excited about here today?
Yeah, I can definitely, thank you. We have a long background in nanoimprint lithography, so that's NIL, and that's like our name and our legacy. And we started the company 18 years ago focusing on masters for this nanoimprint process. And then 5 years ago, we decided to take a new path. We had some years of profitability, it was going well, but we had greater aspirations. And we decided to engage deeply in the world of nanostructured optics. So today, we are actually still keeping our mastering business, so that runs, but we are fully engaged in the development of mass production of metalenses with a vertically integrated strategy from design and all the way.
So metalenses, I'll admit, this is a term that I hadn't heard of until today, so I'm curious to hear it directly from you, what that is and maybe what that means for different applications that your customers work in.
So metalenses are essentially it's a diffractive lens, but you are patterning a surface with a lot of nanostructures that each of them works as a resonator. And eventually you can actually take a curved surface and replace it with a flat nanostructured surface. And because you have lithographic precision over these nanostructures, you can actually create a more wave function. You can have more functionality in one surface than you can with a curved lens. So as a rule of thumb, we say we can take the performance of 4 lenses and integrate into one flat surface.
Mm.
And so the advantage there is compact size.
Compactness,
right?
yeah. So size, we call it the swap, so size, weight, and power. So we have, when we are building systems, and today also brought a sample of an eye tracking camera, or a very, very miniaturized camera consisting of only metalenses here. And we reduce the number of surfaces also in the system, so there's less stray light, we have more control of where the light is going. Of course, you can argue that it's diffractive, there's always some higher diffraction orders, but we can control where they go. So we control the system and create some very mind-blowing performances with an extreme compact form factor. And I think that also answers the second part of your question. So that is what excites me the most. It's actually what we are bringing to the show here.
Yeah.
We have got a lot of attention. I think it's the first time someone demonstrates a camera consisting purely of metalenses where that's more than one metalens in it. And I think this is something very new, something we worked on for a long time.
So eye tracking, I'm going to ask you about some of the other applications too, but I want to start there. What are some of the benefits of having such a small camera for eye tracking applications, and what might some of those be? I mean,
you get very fast inspired from the show at the other side of the street, SPIE, AR, VR, MR, and there you'll have devices that you have to wear on your head-mounted devices. And so anything that's light, very small, I mean, that's more comfortable to wear, that's the first thing. Secondly, the full vision of AR, you want to wear glasses like you are wearing, and you want to integrate sensors and eye tracking systems in that. And you basically don't want to notice them, right? You just want to benefit from them. Mm. Yeah.
So by tracking the eye in an AR, VR headset, you can optimize the performance of the...
It's a human-machine interface, right? So you have your hands free and you can basically control whether it's an imaginary screen and a cursor, you can control whatever panel or, yeah, with your eyes. It's quite mind-blowing when you try it for the first time, yeah.
Yeah, I think it was 2016 when I was editor-in-chief of Vision Systems Design magazine, I received a phone call from a gentleman, and he was saying, you know, we optimize resumes. He was like a professional kind of job placement person, you know, and we want to optimize the resumes we write for people, and we want eye tracking technology so that we can see how people read these resumes.
Yeah.
And this was before AI probably just reads all the resumes now, but this was, you know, back in 2016, I think. And yeah, so like eye tracking, one would be tracking the eye to see how someone looks at something, right? What are the other applications for eye tracking besides AR, VR?
Another area would be within the automotive industry. Build it in to make sure that you are paying attention to the right things when you're driving the car.
Yeah, and your eyes aren't going.
There's drowsiness. You want to avoid that, but
or
you
distractions.
also, distractions. You should keep your phone in your pocket, right, when driving. So
if you're looking down,
exactly. So I think that's just what I can come up with. And if you really start thinking about it, I think it's also all the touch panels, in public places, and then now they place, alcohol next to it to disinfect. But what if you could just control whatever you're ordering with your eyes?
A kiosk, or ATM machines, or all kinds of things, right?
Like that.
There's a lot of, I don't know if you ever saw the movie Minority Report.
I think I've seen it, yeah.
Yeah, it just reminds me of it's almost, there's a scene where I think it's Tom Cruise, he's walking through a mall, and when you look at this billboard, it's not a billboard, it's more of just an LED screen ad. But when he looks at the ad, it's customized to him,
Exactly.
and serves up something in particular. And I don't know, technology like that is maybe not as far away as others.
No, I think that could definitely be realized today if people put their shoulders to it. I guess maybe that already have been realized. Yeah.
Beyond eye tracking, what are some of the most common applications where your metalense technology is deployed?
We're looking a lot at 3D sensing. Again, miniaturizing the optics. Sometimes, we are doing some reference designs and are showing what it can be done, but we also have customers that brings in the design, and we're just realizing lenses for such purposes. But again, miniaturizing the optics, the modules, such that you don't really see it. And there are different technologies there, time of flight, structured light. And also here at the show, we're demonstrating, again, a multiple meta-lens camera for eye-tough, indirect time of flight, 3D sensing. So it's cool, yeah.
So time of flight, I know that time of flight sensors in industrial automation, for example, are used in a lot of different ways in the warehouse and beyond. But if yours is miniaturized, what are maybe some applications where a smaller time of flight camera might be used?
I think again, it's really the areas where you are mostly volume or size restricted, but also weight, right? So we're all wearing wearables. The phones for sure, other type of wearables.
Yeah.
You could think of drones also, like where weight would become an important factor. So that is consumer electronics, and again also cars. That's not that big a difference from some of the optics you're creating, whether it's a 3D system, sensing system for a phone, or it's a LiDAR for a car, right? So again, many of these 3D systems both have a transmit side, where you are illuminating a scene either with a diffuse light or a dot projector, and a receiver side. So we're doing both these sides. So and that's very similar in the LiDAR, both for medium range detection and long range detection. Yeah.
You talked about being vertically integrated. Could you talk more about what that involves in your context?
Yeah. So when we started looking at metalenses 5 years ago, we were met with a lot of questions about basically efficiency. How much light do you lose to higher order diffraction orders? So that was the first task we really looked into, and we realized we had to design our own simulation tools to design these metalenses and make sure that we could design according to our prototyping and manufacturing process. And a few years ago, we managed to create a focusing lens with 94% absolute efficiency. I was like, okay, this is so close to the theoretical limit that okay, now we have the fundamental building block in place. So we've been expanding that design box. And now, so we're designing all our metalenses ourselves. When that is said, we can work with other people's design. We'll come back to that. And then a lot of people had the question about, can you just drop in a metalens into our system? But we realized since metalenses are diffractive and many existing systems are more refractive, the module has to be designed to benefit from the metalens properties. So we're looking a lot on systems and making reference designs and showing people what can be done. So that's the design part of it. We are then prototyping it using all in-house tools, electron beam lithography, etching, and have optical characterization labs and testers, reliability testers. And then we do manufacture by nanoimprint lithography and etch. So that's a very similar process to the e-beam and etch that we do for prototyping. So we are setting up manufacturing. We have the first line in Europe for prototype volumes and small volumes, and we're building a mass production line as we speak in Asia.
And what type of volumes are you expecting to be able to achieve?
I mean, we are looking at consumer electronics volumes in whatever shape they come in. So we're ambitious, but I cannot comment much more on the details there.
Yeah, understood indeed. I do want to go back rather and ask a little bit about AR and VR because it seems to be a growing it is a growing focus here at the SPIE show. What's your take on that? So AR, it's big in gaming and entertainment and some of these virtual concerts and things like this, or experience a soccer game or a basketball game through the glasses. That kind of thing is cool, but it's expanding into industrial too. Like, what were you talking about, John? Like training or troubleshooting, or engineers might be looking at a part together. What's your sense of the AR market? Is it becoming more mature?
I think it is. There's also another cool applications within surgery and medical assistance, right? I think it is, and I think there's so many things happening that it's starting to become so relevant that it's coming to stay now. I think there's a big thing with the spatial computing coming out lately, right? That's gonna, I think it's next week. They're gonna launch that, and that's very interesting. I think it's Ray-Ban and Meta took an approach from the other angle, right, to creating sunglasses with cameras in, and I think actually that it's very important that people start to think of sunglasses as something you need to charge. I think that's actually a small thing that it makes me smile when I realized it. But actually sunglasses are now a thing that before you leave you have to make sure that they are charged. And I think that's actually one of these nudging things of how we perceive things and how we familiarize ourselves with new things. I think it will come.
John would hate to charge his glasses. I know that.
Yeah, I think it will happen.
What are you touched on this a little, but what are some of the unique optical challenges in AR, and how are metalenses uniquely suited to these applications?
So, I mean, actually, we are involved in the AR from two different angles. So, we actually still doing making masters for customers, and especially for making AR waveguides for the industry. So, we are very much involved in that, and that's maybe the area where my company is the mostly exposed to all the development efforts that there are, and we're having some deep programs in optimizing how complex and nanostructures we can do on the master level, such that people create very, very highly efficient waveguides for the glasses. When it comes to these more compact systems with cameras and sensors, I think we don't see requirements that are, in many aspects, that different than they are from other industries. Like there's a need for, again, the swap, right? Size, weight, and power, and people are very interested to see what we can do with this new technology. I mean, now this is a podcast, and so I think maybe people cannot really appreciate how small this camera is. But much fewer surfaces in this whole camera system, simple to assemble, very, very robust. There's no plastic in it, temperature stable, and these things. So people appreciate that.
Mm-hmm. Yeah, that camera, I don't know, it looks like maybe the size of a long grain rice.
Yeah,
or something. It's very small.
Or maybe half a rice.
Half a rice, yeah.
1/3.
Yeah, it's pretty small for those that can't watch this.
Yeah.
But you had mentioned the eye tracking camera and the depth camera. Other cameras you're working on, other types of cameras?
We have, already last year we demonstrated here at the SPIE an extremely simple camera, which would be, we call it the 1M camera. So it's basically one nanostructured surface in front of the sensor. It's a little bit of a rigid optical system, but for machine vision purposes, this is ideal and very, very simple. So that is also something that's one of our fundamental building blocks in our whole understanding of how to build modules, how to build cameras using this type of technology. So
that may be for like, I went to a presentation once by a Roomba design engineer who developed a machine vision system that's in a Roomba robot. And I think of like these mobile, portable, compact, applications where they need a camera. Is that where you might see these types of things?
Yeah, and I think there's a lot of things happening these days. AI is coming, right? So you can do a lot on the signal processing side. So the first thing you have to ask yourself is like what the camera sees. Is that intended for the human eye, or is it intended for a machine to interpretate? And if you really go that way, you can sacrifice certain optical parameters that you normally would appreciate to maintain in a photography that is intended for the human eye, and sacrificing such things and then optimizing on compactness. Mm-hmm. Then you can really create something, but it has only a functionality together with an algorithm that looks at it. So this is where my company is. We are working with other companies because we don't have that side of it. Mm-hmm. We're looking at the hardware and focus on the manufacturing of the lenses and demonstrating what we can do in modules. So combining those two things, that's where the magic really starts to happen. And that's also in that space where I see metalenses today is actually mostly in the near infrared, the SPIE region, visible region, but still monochromatic. And there's a lot of interest in bringing metalenses to broadband visible. And I think that will happen when you combine the metalenses with the signal processing. Mm-hmm. So from our perspective, making a metalens in the near infrared and SPIE, we're etching into silicon. When we have to make a metalens in the visible spectrum, we're working with a different material. So we have the processes to make these lenses, but we're not putting equally much effort into the design in the visible space yet. But if customers have their own design there, we can process them for sure.
So beyond the chargeable, portable sunglasses, right? What are some? Do you have any general predictions or trends that you expect to see in the coming years, and within the purview of, let's say, the photonics space, machine vision, industrial?
This is terminology of ubiquitous sensing, right? We more data, more high accuracy data, basically to make better predictions and better decisions. I think that's one area. Another area is new type of sensing. Hyperspectral. Different type of spectroscopy. Mm-hmm. Whether that is air quality, skin hydration, food freshness, authenticity of certain things. Mm-hmm. I think that is a very, very interesting area. Mm. Yeah.
Theo or John, anything else that we haven't talked about here that you feel like we should be covering?
Nothing for me, Jimmy. Thanks.
No, thanks for having me, and thank you for the opportunity to tell you.
Of course. I know how busy your day must be, so I really appreciate it. It's for anyone who would like to learn more, it's nilt.com. And if you have questions or comments, we would be happy to pass them along to Theo. You can reach out to us at manufacturing-matters.com, and thanks very much.